big giant organic molecules, it couldn't detect. So we don't know. We want to go back. Now, another moon of Saturn that gets a lot of attention is Titan, its largest moon. And when Voyager first went there, this is what it saw. Again, that doesn't look like any moon I ever known before. It's a moon with an atmosphere. The only one with an atmosphere. Not just a little bit of atmosphere, we're talking thicker than Earth's atmosphere. Surface pressure 50% higher, surface density 4 times that of Earth's. There is a thick haze that covers it in orange. There are hydrocarbons, basic organic compounds, a lot of methane. So we, in one of our most audacious moments, you think that it was amazing to land on the moon or Mars, we had tons of maps of the surface from orbit. We decided, let's land on Titan with pretty much nothing more than this, big orange fuzzy ball. Said, let's land there. So Cassini carried the Huygens probe, it got there, it released it, Huygens descended through this thick atmosphere for 2.5 hours and finally broke through the haze to reveal the surface of Titan that no one had ever seen before. And it looked awfully familiar. River channels, clouds, mountains, sand dunes. Cassini's radar saw through the haze, just like we did with Venus. Sand dunes and deserts dominate the equator, but they're not made of sand like we know. This is a world where the surface is made of water, ice, and the sand dunes are made of snowed out hydrocarbons. So this is a world where it snows plastics. Interesting to think about. And when we landed, we saw that all of those rocks and surface are water, and all the orange snow is those hydrocarbons. But even more fascinating was what we found at the North Pole. And at the North Pole, we found these big dark spots. They're lakes. They're huge lakes, some of them. The largest one bigger than Lake Superior. Now, it's negative 300 degrees on Titan. There's no way these lakes have liquid water in them. Water on Titan makes the ground. These are lakes of liquid methane with some ethane and nitrogen mixed in. So the things that we think of as natural gases here on Earth, it's so cold here that they go liquid. It rains methane, it runs through rivers, gathers in lakes, and then it gets re-evaporated up. This is the only other place we've ever found other than Earth that has a hydrologic cycle active on it right now. This is art, I must say, but it gives you a beautiful idea of what it might look like if you could stand on Titan near one of these lakes, staring out over this beautiful canyon carved out of water ice with all of your hydrocarbon, orange snow everywhere, with your liquid methane and nitrogen running down into a great lake or sea. So it's a fascinating place, and we're already planning for going back to Titan. Titan also does, by the way, have a subsurface ocean too. Let's not forget that part. So Titan is a fascinating target for us. Now, once we get out past here, the information gets a little scant, and that's because as we move out now to Uranus and Neptune, only Voyager 2 has visited these worlds, and all it did was fly by. So we have only a few images. Uranus, of course, is famous for being the planet that's tipped on its side. So the rings are this way, and I've left it tipped as it should be. And it has a few moons, not quite as many as Jupiter and Saturn, but it has about, I think, 15. And one of them is, we wanted to talk about the rings of Saturn, didn't we? We're going to have to save that for another time. Let's see here. Let's go through really quick. Gorgeous rings, gorgeous rings, gorgeous rings, because I want to have time for questions. Weird looking moons, right? Okay, you want to talk about weird looking moons. These are little bitty moons. If you just go up one, we'll mention, what are those? They're called shepherd moons. They're only a few miles wide, and they're what keep the rings there so nice and even with all those beautiful stripes and lines and everything through them. And yes, when we go to the next one, when we got our first up-close pictures, we really said, what the heck is that? Because it doesn't look like anything we'd ever seen before. So we find lots of strange stuff. All right. So Uranus's moon Miranda is an interesting little story. Something hit Miranda and split it apart to the core, and it started to drift apart in pieces. But then gravity just managed to bring it back together. Unfortunately, not necessarily put back together the way it was. So that's why it looks like that. It always reminds me of when I tell my kids to put away the Play-Doh, and they just start picking up pieces and shoving them together in any old way. So you can see that, like this, probably was once inside the moon, but now it's been split apart and shoved back together in a different way. So that's a great thing, because we could go there and check out what does a moon like this look like on the inside, because parts of Miranda are turned inside out. Next. All right, now I was taught that all 4 outer planets were gas giants, but that's actually not true. Uranus and Neptune are more accurately ice giants. Even though they have a very thick gas layer, the planets are mostly made of water ice, with some organics mixed in, methane, ammonia. If you're hearing a theme here, you're right. The outer solar system is filled with water and organics. And we think that that's actually where they got to Earth. Earth, it turns out, is too close to the sun for water and organics to have formed with the Earth. We know that they had to have come to Earth after the surface cooled and solidified. And we believe that asteroids and comets from the outer solar system, where it was cold enough for the water and the organics to be, delivered life to Earth, the building blocks of life to Earth. So even though you normally think of asteroids and comets crashing into Earth as life ending, they're actually life beginning. Neptune's largest moon, Triton, is a fascinating world for which we have one picture. But in that one picture is so many questions. Down here, those huge shadows, it has active geysers on it, shooting stuff out, maybe another subsurface ocean. All that weird looking stuff to the north that we call the cantaloupe terrain, because that's exactly what it looks like, we don't even know what that is. We don't know what causes it. But this is it. This is all we have until we go back again. Now, a brief word about Pluto and the whole why isn't Pluto a planet anymore. There's Pluto and its largest moon, Charon, and let's not forget about Ceres, about the same size, right, on the order. Now, up until about 3 years ago, this was the best picture of Pluto we had, Hubble Space Telescope. And I grew up not having any idea what Pluto looked like. I was often told, probably looks like Mercury or the moon or something like that, but ultimately nobody knew. And this is the glory of going somewhere you've never been, is that when New Horizons got to Pluto, after traveling for 10 years, our images of Pluto went from this to this in literally a matter of days or even hours. We now know that Pluto has 5 moons. And we also now see from this that no, it doesn't look like Mercury. It doesn't look like a moon. It looks like Pluto. It's its own world. Next. Try next again. There we go. It has mountains the height of Everest. Next. Huge, vast ice shields. Something is geologically active on this world. And my favorite shot, the parting shot, as the spacecraft left and saw the atmosphere of Pluto. So why isn't Pluto a planet? Turns out Pluto's not alone. Pluto, when it was first discovered, was thought to be all by itself, and so they didn't know what else to call it. Although it seemed odd, and many people thought it just doesn't seem to fit with the other planets. Once we figured out that Pluto's actually part of another asteroid belt called the Kuiper Belt, then it started to make sense. Pluto and Ceres and all of these other bodies are all in the same class. They're smaller than planets and they're part of asteroid belts, and we decided to give them their own special name. They're dwarf planets. And I think Pluto got an upgrade, because instead of being the smallest weird planet, it's the biggest dwarf planet now that we know of. So I'm happy for Pluto. I think that's cooler. So beyond this, there's really nothing but the Oort cloud, which is where we think a lot of comets have come from. But we have sort of reached the edge of the solar system. New Horizons, though, is not done. Because after passing by Pluto, we looked and we saw we had just enough fuel to nudge ourselves toward another Kuiper Belt object. It's called Ultima Thule, just recently named, and we're going to get there New Year's Day. This coming New Year's Day. And another world is going to go from knowing nothing about what it looks like to seeing the surface, and we get to see Does another Kuiper-Belt object look like Pluto, or does it look completely different? We don't know. And the nice thing is now we have the internet, and we don't have to just have this be an experience of the few people that are in that room at Jet Propulsion Laboratory. You guys can all watch it live too. You can watch this happen on New Year's Day, watch this new world that we've never seen before, the farthest thing we've ever explored, come into view and into focus. And so that concludes the tour of the solar system. And I'd love to open it up to hearing questions from you about the planets or about me or whatever you'd like to know. And also, if you'd like to come up and get a closer look at the magic planet, please feel free. Yes?
So you said you got a bachelor's degree in astrophysics?
Yes, and mathematics. I got 2 degrees.
Okay.
Because I just loved college that much.
So what did you do with the Mars rover then? Were you involved in like design, or were you mostly just figuring out the trajectories and whatnot?
So design, I was not an engineer. I did help with some of the camera calibrations because when you're on a tight deadline to meet a launch, everyone chips in. But no, I wasn't part of the design, but I was part of the science team, so the job there was basically every day we get fresh images down. Basically, every night on Mars, we would get what the rover did that day, and then we'd have overnight to look at it, make some quick hypotheses, and decide based on that what do we want the rover to do next. And then we'd have to have those ready to be delivered as new commands to the rover the next morning. The mission critical ops that I did was a role called documentarian. And that meant that I and the chair of the science team that day would sit together and I'd record everything that happened in the science meetings. The important thing there was what did people want to do and what priority was it? Because you never got everything you wanted. And at the end of the science day, the scientists all had to leave while the chair and I stayed and went into the tiny little room with all the engineers that were actually going to build the code. And we had to be there to guide them, and my notes had to be there to guide, and we had to make tough decisions sometimes about cutting things that the scientists wanted. And so it was a very analytical thought and science prioritization, and you had to have a general science knowledge in order to know how to make good decisions and cut things in a way that would still yield good science. So that's over there.
So we were talking about how it took like a few hours or a few minutes actually for the instructions to get to the rover when they were still landers. Like to like warn them about certain things. Like what sort of things would you warn them about though if they were on the planet?
So we pick a landing site. So what kind of things would we worry about with the rovers running into? We pick places on the planet that already are pretty flat and easy to land in. But the rovers might encounter a rock that was too big, a rock that was big enough where it drove over it, it could gouge the undercarriage, or that the wheel could get stuck on. Maybe there would be a ridge that would be too steep and the rover would tumble down it. So we still knew that there were these hazards out there, and the rovers were basically given enough AI to avoid these hazards on their own. And they did this by using 2 HAZ cams on the front and 2 HAZ cams on the back, tiny little cameras with fisheye lenses. And they would literally drive a little bit and then they'd stop and take pictures. And they'd process and say, okay, I can keep going. They'd drive a little bit further and then they'd stop and take pictures and make sure everything was okay. And this is why they moved very slowly. At least until we saw that Opportunity got up out of that crater, and that Meridiani Planum, except for a few craters, is like the flattest place you can imagine, just tiny little sand ripples and that's it. And we literally turned that off and just had it drive because there was nothing to run into. And so because of that, Opportunity was hoped to go 600 meters in 3 months. In 14 years now, we've just passed 45 kilometers. 45,000 meters. So we were able to drive a lot faster than we thought we could by turning that off and just saying, trust me, just drive straight, there's nothing there, you're fine.
And also did you like make them like all terrain too, so they would be okay, or?
We did design, it's called, the 6 wheels is a classic design that we have been using since the very first rover. The system is called a rocker bogey system, and it's designed basically in what's called the sandbox at JPL, where we have it drive over rocks and terrain, and we picked the design. We tried 8 wheels, 4 wheels, tried all different things. But yes, they're designed to be able to handle rough terrain very well. There's another hand up over here somewhere. Oh, we got a question over here.
Even though most of the planets aren't inhabitable right now, did we believe that every planet at some point was something?
Mars is probably the only planet that we think in the past could have had at least life as we know it. And this is where scientists have to choose their words carefully. Life as we know it is really the only life we know how to detect. And when you start looking at places like Europa and Enceladus, they have environments that match Earth environments. So again, we think possibly life as we know it. They're moons, not planets. The other planets probably don't have any life, but the only thing we know for sure is not life as we know it. A fascinating thing about Titan is the idea that maybe it's not the water that's necessary to life, maybe it's the liquid part of the equation. And so even though Titan is so cold and all the chemicals are different, people wonder if there couldn't be life as we don't know it on Titan, simply because of that hydrologic cycle, because there is active liquid on a solid surface. Maybe it's the geology that matters, not the chemistry and the temperature. And so people are considering that there could be life on Titan, but not life like we know it here, something chemically different, but still life. So it's kind of an open question. If you want to narrow it to life as we know it, then yes, Earth is the only currently habitable environment, with the exception of maybe Mars deep in the subsurface where the groundwater still exists. There could be bacteria down there. It's going to be hard to find though. But if you want to expand that to, well, maybe life as we don't know it, then you've kind of opened the floodgates to who knows, right? And would we even recognize it when we saw it? It's a tough question. Yes?
Do you think personally that there is life out there somewhere?
Definitely. I think that most scientists have come to the consensus that they'd be shocked if there wasn't. And when you say life, I mean, when you say that, we think bacteria or pond scum or the most basic you can. Intelligent life, I just think the vastness that statistically I can't imagine that never happening again. It becomes a question of just how frequent, how common. Now, a lot used to be unknown that we now know, and that's one of the things is planets. For a long time, we didn't know if other stars had planets. We assumed that we're probably not the only one, but we didn't know how common they were. Now, thanks to the Kepler telescope, we have discovered over 2,000 planetary systems and over 3,000 planets all around other stars. Now we know that planets are actually common, they're the norm, and we're finding that our solar system is not typical. In fact, like looking at Pluto, there seems to be no typical solar system. They're all over the map, they're all different. So I look at that and I think, you know, I also studied mathematics, I studied statistics. The statistician in me says, I have a hard time convincing myself that this is the only life in the entire universe. It just seems so unlikely, knowing everything that we know now, that my brain can't accept it. But we have no evidence up until now, so I can't say for sure. Yes?
Are you guys looking into like going out of the solar system anytime soon? Or?
Yes, we are definitely. I mean, Voyager 1 has left the solar system, so we have a spacecraft that has entered interstellar space. In Ithaca, we have the Sagan Planet Walk. The sun's at the center of the commons. Pluto is 3/4 of a mile away. It's a 1 to 5 billion scale model of the solar system. It actually doesn't end at Pluto. It extends all the way out to our nearest stellar neighbor, Alpha Centauri, the next star over from our sun, 4.5 light years away. That, on that scale, so sun to Pluto is 3/4 of a mile. The next star over is in Hawaii. With our current rocket technology, we could get there in about 700,000 years. But we are looking into ways that we might be able to cut that down to a century or so. Certainly not sending people, sending like microscopic satellites. We can now make microscopic cameras and stuff like that. Sending those very, very light at very quick speeds. And actually, before he died, Stephen Hawking was starting a project just like that, and it's going to be continued. This idea of, can we send microprobes at close to the speed of light and maybe reach there within a century instead of almost 1 million years. So interstellar space is really empty, and it's very hard to cross. Yes? Yeah?
Would it ever be possible to physically be able to put anything on Venus, or is it like too hot or anything to physically be able?
Well, we did have 2 landers, right? We did successfully land twice, and actually NASA is looking into sending a new Venus lander. As we said, Venus might not seem like an interesting place because it's so different from Earth on the surface conditions, but geologically it's of great interest. So we are looking to land on Venus again. It is one of the more difficult places to land because of all of those obstacles, the heat, the pressure, and the acid, and all that stuff. But yes, we can land things on Venus. We have, and we will continue to do that. Mars also is hard to land on. And the reason for that is on Earth, you have an atmosphere that can burn you up. That's a danger, but at least it slows you down. Landing someplace like the moon with no atmosphere, well, you don't have to worry about burning up, but you do need to worry about how are you going to slow down, right? Mars is the worst of both those worlds. There's just enough atmosphere to burn you up, but not enough to really help you slow down. So one of the things that we're limited with landing on Mars is elevation. We have to only land in low elevations because we have to get through enough atmosphere to deploy parachutes at supersonic speeds to help us slow down. You could not land at the top of one of those volcanoes. You wouldn't pass through enough air to slow down before you crashed. So landing anywhere is a trick. Titan actually is a pretty easy place to land, right? Nice, cold, thick atmosphere, just deploy your parachute and drift, right? Yeah?
Is there any explanation for most of the planets being uniform compared to Earth with its like vast amount of atoms?
By uniform in what way?
Like, there doesn't seem to be much variation in the coloration of the surface compared to Earth with there's like rainforests and deserts and stuff like that.
So the variation in color, Earth has pretty much blue, white, brown, green. And the blue and the white, of course, are coming from water, and then the green is coming from life. So if none of the other planets have life, then you don't have the green. None of the other planets have something like a solid and liquid surface, right? Now, Jupiter has lots of color variations. Even though it's all clouds and deep down liquid, it has lots of color variations. Saturn has some if you look at it in different wavelengths. A place like Mars looks pretty ubiquitous because you're kind of looking at the same thing all the time. But Titan, of course, if you could see it, you would see variations there too. It wouldn't all be orange. You'd have the dark methane lakes as well. So yeah, some of them can seem rather ubiquitous, but what we're finding is we now know over 3,000 planets is planets come in all shapes and sizes, flavors that you could possibly imagine. And our solar system is by no means typical. And some of them out there, Uranus and Neptune, yes, they look very not monotone in their color. And part of that's due to how cold it is. But yeah, they're each their own color though. So that's a good question. Earth looks the way it is because it is special, right? Good question right here?
Is NASA getting more space shuttles to figure out more planets when the sun blows up in a few billion years?
All right, so we got someone here that's concerned about what's going to happen when the sun blows up and Earth gets destroyed. It is so far away that we are not necessarily worried about that at this point, but we are certainly looking at space exploration, one of the motivations being living off of the Earth. So having a permanent colony on Mars, on the moon. Venus, you might say, what are you crazy? Humans on Venus? Nice thick clouds, how about a nice floating colony? Up where it's not so hot. Hey, solar power, abundant, you're closer to the sun. So maybe we'll have our own cloud city, you know, like in Empire Strikes Back, Desmond. So we definitely are there with the idea of acknowledging that Earth is going to change. It has always been changing, it will always change, and humans are all about using technology to overcome change, to kind of avoid evolving to some extent. And so we're certainly looking at it from the point of view of we should have other homes, right? We shouldn't just stay on the Earth. And in fact, 4.5 billion years. We actually don't even have that long because the sun is gradually getting hotter as it burns up its fuel. In only 1 billion years, Earth is going to be too hot to have liquid water. So sorry, if you thought you had 4.5 billion years, sorry to burst your bubble, you only have 1 billion. So plan accordingly. All right. Oh, got one here.
You may have already said this, but is Voyager 2 still sending things back to Earth?
The Voyager spacecraft are both still sending messages back to Earth. We just powered up Voyager 1 again, and it came online. So yes, we are still in communication. We're not in constant communication, right? We shut them down for long periods of time, but we are getting information back. That's how we know that they have passed into interstellar space. We've made measurements of the solar wind and how when you get out to interstellar space, you can no longer detect the sun's solar wind anymore. It's just the calm between the stars. And so, yes, we are still occasionally in contact with those Voyagers. Yes?
When do you think we will officially be able to colonize planets, actually get an establishment on a planet?
That's a hard question to answer, but I certainly think not that long if we commit to it. I mean, you look at what happened when Kennedy said go to the moon, and we went to the moon. To some extent, it's just a decision to do it. There are a lot of obstacles to overcome. We don't have all the answers to how we're going to do it, but if history's taught us anything, it's that I have no doubt we will be able to do it. So we just have to decide. And I think that if we really decided with the amount of commitment that we put into the Apollo mission, we could probably have a permanent colony there in 100 years. So it's just a matter of, do we want to invest the time, energy, and money into that? It's certainly doable. We're certainly working on it, I'll say that.
And another one, too. Do you ever think you'll be able to establish a colony in another solar system?
I would say it's not impossible. It's going to be a lot farther off.
It's just way beyond your head.
Yeah, I mean, Alpha Centauri, our nearest neighbor, actually does have planets. We don't think the planets could be habited because the stars are unstable. They sometimes send out huge bursts of radiation, which probably wouldn't be good for life on those planets. But we would need to either figure out a way to travel really fast or figure out a way to go into stasis for that kind of flight. But is it possible for humans to do that? Absolutely. Probably, though, a lot farther off than getting to Mars. Yeah?
How long do you think until they actually put a man on Mars? Not a colony, just a man.
Or a woman.
Yes, that's good, yeah.
Again, it really depends on what kind of commitment you want to make. If we were granted infinite resources, infinite money, do whatever it takes kind of thing, I think like the moon mission, we could probably be there in 10 to 20 years. Will that actually happen? Probably not. So right now, I think we're all looking at more like 20 to 30 years. But that means you kids in the audience today, you might be of that generation. There's actually a lot of argument for the first Mars mission being all women. One of the things that happens, a lot of bad things happen to the human body in space when you take gravity away. One of the things that happens is the vision goes blurry in most people that go into space. For some unknown reason, when they come back to space, the men's vision tends to be permanently damaged, whereas the women's vision tends to come back. You certainly don't want to get to Mars and need glasses because there's no optometrist there. So one of the ideas is maybe until we figure this vision thing out, we should send women. Another thing is that for the same physical labor, women consume fewer calories. And when you extend that over a huge mission like that, that's a lot of savings on food. So there are some arguments to be made for that. Yeah?
What's the current position in interstellar space? I've heard over the years, there's debate on whether or not Voyager can actually get that point or not.
Right, where does interstellar space begin? There are several boundaries that get crossed. There's a bow shock of solar wind, then there's a pause of calm, and then there's another boundary. Voyager 1 has now decided that it has passed all of the boundaries where you could possibly define interstellar space and is now beyond them. But yeah, there's a couple of different places where you can decide, okay, that's where the solar system ends. Like what you call a planet or a dwarf planet or an asteroid, it is something that humans decide on what's going to be called. And yes, there was a lot of debate as it passed through that middle region, but it's now outside of it. It's definitely outside. It is in the space where it can no longer feel the effects of our sun dominating it. It can't feel the solar wind dominating, it can't feel the gravity dominating, so now it's considered to be officially in interstellar space. But yeah, it's important to realize that these things don't have little road signs like when you enter, Portland County. There's nothing like, you are now leaving the solar system. Nothing does that. We have to decide what that means. That's it. So, yeah, as you get up and exit, if you'd like to come down and take a closer look at the Magic Planet, please feel free to do so. Thank you, everyone.